Good morning, my dear students. Welcome to the discussion on the subject Engineering Graphics. Under Engineering Graphics, we are going to discuss a topic on development of surfaces. Under development of surfaces, we are going to discuss a solved problem on radial line method. This is the fifth solved problem we are discussing under radial line method under the topic of development of surfaces. Now we will enter into the problem. The present problem which we are going to discuss is very important and it was asked many times under university examinations. In most of the problems which we discussed under development of surfaces, the problem's information is supplied in the form of a theoretical information, whereas in the present problem, in addition to the theoretical information, figure also supplied in the problem. Now I will read out the problem and extract the information from the problem.
The given problem is a hexagonal pyramid of base side 30 mm and axis 60 mm rests on its base on the HP with a side of the base parallel to the VP. It is cut by a planes perpendicular to VP to obtain the front view as shown in figure. Draw the development of the lateral surface of the retained solid. This is the image of the front view of a hexagonal pyramid when it is resting on its base on HP with one of its base side is parallel to the VP. After cutting this hexagonal pyramid with two section planes, this retained portion is left over. This retained portion is to be developed. This is the first section plane and this is the another section plane. Then this portion of the material is retained. This portion of the material is retained. That is, this retained portion of the lateral surface of the hexagonal pyramid is to be developed. Now we will write the data related to the given problem. Here the name of the object is hexagonal pyramid. This is the hexagonal pyramid and its base side length is 30 mm. Axis height is 60 mm. This pyramid is resting on its base on HP so that one of its base sides say BC is parallel to the VP. In this position, we need to draw top view as well as front view of the hexagonal pyramid. In the case of projection of solids, first we need to start with true shape of the base of the solid. Here the true shape of the base of the solid is visible in the top view. In top you will get true shape of the base of the hexagonal pyramid, that is regular hexagon with one of its sides say BC is parallel to the XY line. After drawing the top view, then we will draw its related front view. This is the image of the front view of the hexagonal pyramid when it is resting on its base on HP and one of its base side parallel to the VP. After cutting the hexagonal pyramid with two section planes, this portion of the hexagonal pyramid is removed and this portion of the hexagonal pyramid is removed. Then the retained portion is left over. Now this retained portion say P, this dark lines region, this P portion is to be developed. Here our objective is to develop the lateral surface of the retained solid. In the case of front view say this is A dash, this is B dash, C dash, D dash, E dash, F dash. That is B dash to C dash is nothing but base side length of the hexagonal pyramid, which is equal to 30 mm. For the development of the lateral surface of a part B portion of the hexagonal pyramid, we need to follow three steps. The first step is drawing top view as well as front view of the hexagonal pyramid. Second step, drawing section plane lines. The third step is to draw the development of the lateral surface of the truncated pyramid. Then we will move to the first step. Now, as a first step, in the case of projection of solids, what we need to do? We need to draw with true shape of the base of a solid. Here the true shape of the base of a solid is visible in the top view. this hexagonal pyramid is resting on its base on HP, so that one of its base side is parallel to VP. So in top view, we are able to see the true shape of the base of a hexagonal pyramid. That is, true shape of the base of a hexagonal pyramid is obtained on the horizontal plane with one of its base sides, say BC, is parallel to the XY line. So with 30 mm as a side length, construct the regular hexagon so that this BC side is parallel to the XY line. As a first step under drawing top view as well as front view of the hexagonal pyramid, draw XY line. After drawing XY line, then we will draw true shape of the base of a hexagonal pyramid, that is regular hexagon with one of its side, say BC, is parallel to the XY line and its length is 30 mm. So construct regular hexagon with BC side parallel to the XY line. So draw side BC and its length is equal to 30 mm and it is parallel to the XY line. Then construct the regular hexagon here. For construction of the regular hexagon, we are going to use circular method. This is the image of the true shape of a base of a hexagonal pyramid when it is resting on its base on HP and one of its base sides, say BC, is parallel to the vertical plane. Here O is the image of the apex point in top view. Then we need to draw the image of the slant lines, say OA, OB, OC, OD, OE, OF in the top view. For that we need to join the points, say O2A, O2B, O2C, O2D, O2E and O2F with straight line segments. Here OA, OB, OC, OD, OE and OF are the images of a face edges of a hexagonal pyramid in top view. With this we completed drawing top view of a hexagonal pyramid when it is resting on its base on HP with one of its base side is parallel to the vertical plane. Then we will move towards drawing its corresponding front view. For that, draw projectors through the points, say A, B, C, D, E, F and O towards the vertical plane. First we will draw projector through the image of the apex point of the hexagonal pyramid in top view, say O, towards the vertical plane. Here the height of the hexagonal pyramid is equal to 60 mm. Then along this line, at a distance 60 mm from the XY line, locate a point O dash. Its distance is 60 mm from the XY line. After that, draw projector through the points, say A, B, C, D, E, F in the top view towards the XY line. Because the hexagonal pyramid is resting on its base on HP, that's why the base image falls on the XY line. So join the points, say A dash as well as D dash in front view. This is the direction of front view. So for the observer, the face edges say OA, OB, OC, OD are visible and OE, OF are invisible, but OE face edge is hidden by OC face edge, OF face edge is hidden by OB face edge. Then join O dash A dash points, O dash B dash points, O dash C dash points, O dash D dash points with continuous lines. This is the required front view of the hexagonal pyramid when it is resting on its base on HP and axis parallel to VP. Make a note, here the pencil used for drawing top view as well as front view of the hexagonal pyramid is 3H pencil. That is, all these lines are thin lines. Then we'll move towards drawing the section plane lines. This is the first section plane line and this is the second section plane line. The first section plane line is making an angle 45 degrees to the HP and passing through the axis at a distance 40 mm from the base of a hexagonal pyramid. So first to draw first section plane line. Then locate a point at a distance 40 mm from the base of a hexagonal pyramid, that is 40 mm from the XY line along the axis. Then this section plane is making an angle 45 degrees to the HP. So draw 45 degrees line and that 45 degrees line need to pass through this point on the axis. Drawing first section plane is completed, then we will draw second section plane. The second section plane is drawn with a radius of say 30 mm from the right hand side corner, say D dash corner, that is with D dash corner as a center, 30 mm as a radius, that is this distance is 30 mm. So with this 30 mm as a radius, D dash as a center, draw an arc. Then dark the lines under the region which is to be developed. Here our objective is we need to develop the lateral surface of the part P portion of a hexagonal pyramid. For that we are going to use radial line method. For that we need to draw the arc with O as a center with true length of the slant height as a radius. For drawing the development of the lateral surface of a hexagonal pyramid with O as a center, we need to draw an arc with a radius is equal to true length of the slant height. Here the true length of the slant height is 1 whose image in the top view is parallel to the XY line. Here O dash D dash image in the top view, say OD parallel to XY line. So O dash D dash is called true length of the slant height. O dash A dash image in the top view, say OA is parallel to the XY line. So it is also called true length of the slant height. Then O dash B dash, O dash C dash, O dash E dash, O dash F dash image in the top view are not parallel to the XY line. So they are not called true length of the slant heights. Here we are considering O dash D dash as the true length of the slant height because its image in the top view is parallel to the XY line. Then draw horizontals through say 1 dash, 2 dash, 3 dash onto this true length of the slant height. Then draw horizontal through 8 dash 10 dash onto this true length of the slant height. Then locate the points say 7 dash 11 dash images in the top view of a hexagonal pyramid. Seven dash is the intersection point of the section plane with the base edge of a hexagonal pyramid say BC, and 11 is the intersection point of the section plane with the base edge of the hexagonal pyramid say EF. Locate a point O then O dash T dash, that is true length of the slant height as a radius, that is O dash D dash, that is true length of the slant height as a radius. Here true length of the slant height is 1 whose image in the top view is parallel to the XY line. Draw an arc O dash D dash, that is true length of a slant height as a radius, O as a center. Draw an arc after that name this point as A, then the base side length of the hexagonal pyramid say 30 mm as a radius, A as a center. Draw an arc, with that you will get point B, B as a center with the same radius. Draw an arc, with that you will get point C, C as a center. Draw an arc, with that you will get point D, D as a center, 30 mm as a radius. Draw an arc, with that you will get point E, E as a center with the same radius. Draw an arc, with that you will get point F, F as a center with the same radius. Draw an arc, with that you will get point A. Then join the points A to B, B to C, C to D, D to E, E to F, F to A with straight line segments, and O to B, O to C, O to D, O to E, O to F, and O to A also with straight line segments. This is the complete development of the lateral surface of a hexagonal pyramid. Here OA, OB, OC, OD, OE, OF and OA are the true length of the slant heights of a hexagonal pyramid. AB, BC, CD, DE, EF and FA are the base edges of a hexagonal pyramid. Here base edge length is equal to 30 mm. Then O dash 1 dash as a radius, O as a center. Draw an arc on OA slant edge in the development and name this point as 1. Similarly, O dash 1 dash as a radius, O as a center. Draw an arc on OB slant edge in the development and name this point as 2. Similarly, the same radius, that is O dash 1 dash as a radius, draw an arc on OF edge in the development. Then O dash 1 dash as a radius, O as a center. Draw an arc on OC edge in the development. Similarly, O dash 1 dash also with the same radius. Draw an arc on OE edge in the development. Then O dash 4 dash as a radius, O as a center. Draw an arc on OD edge in the development. Then number these intersection points in the development. Then B7 as a radius, B as a center. Draw an arc on BC base edge in the development. and number this point as 7. Similarly, F11 as a radius. F11 as a radius. F as a center. Draw an arc on FE base edge because 11 is the point on EF base edge. Then O dash 81 dash as a radius. O dash 81 dash as a radius. O as a center. Draw an arc on OC edge in the development. With the same radius, draw an arc on OE edge in the development because O dash 1 dash also with the same radius. Then O dash 9 dash as a radius, O as a center, draw an arc on OD edge in the development because 9 is the intersection point of section planes 2 as well as face edge of the hexagonal pyramid, say O dash D dash. Then this is 8 and this is 9, this is 10. Then join the points, say A to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 1, 1 to A to F, F to 11, 11 to 10, 10 to 9, 9 to 8, 8 to 7, 7 to B, B to A with thick continuous lines, that's to with H pencil. Then draw part of the face edges of the hexagonal pyramid, say B2, 8-3, 9-4, 10-5, F6 with continuous dark lines, that's to with H pencil. Now we'll see the pencil usage details. Here the part peak portion containing lines are with H pencil and remaining lines are with 3H pencil. Here the pink color lines are with H pencil and remaining lines are with 3H pencil. Dimensioning is with 2H pencil. In the case of dimensioning, the base side length of the hexagonal pyramid is 30 mm, axis height is 60 mm, and the first section plane is passing through the axis at a distance 40 mm from the base of the hexagonal pyramid. That means all the dimensions are in millimeters. Make a note, for drawing the arc in the development, we have taken true length of slant height as a radius. Here O dash D dash is the true length of slant height. And its image in the top view is parallel to the XY line. And the method used for the development of the part P portion of the lateral surface of a truncated hexagonal pyramid is radial line method. This is the required development of the lateral surface of a part P portion of the hexagonal pyramid.
If you have any queries or doubts related to the present solved problem, you can mention it under comment section of this video. I'm happy to answer it as quickly as possible. For more videos on engineering graphics, visit the links provided under description of this video. Keep learning on knowledge sharing. Stay blessed. Thank you.